So the first section in chapter 5 is going to talk about random variables, introduce what they are. We'll go through some examples and then understand what a probability distribution is. And from there, we're going to work on things like the mean or expected value from a probability distribution. And we're going to revisit standard deviation and understand what that is in conjunction with the range rule of thumb. So those are all the things you can look forward to in this section. So quite a lot. Well, let me start with the two types of variables that we're going to work with. There's a discrete random variable and a continuous random variable. Now, both random variables are things that take on number values. A discrete random variable can only take on certain number values. It can only take on a finite set of values, so things that you could count. Whereas a continuous random variable takes on any value in some interval. So it could be anything. There's an infinite number of values you could have. So let's get used to the differences here. And we'll do that with an example that should be in the handout that I emailed you. So let me see up here. There we go. Discrete versus continuous. So here's our definitions again. But let's take a look at these and try and get an idea of, what's what. So the idea is to determine whether the value is a discrete random variable, continuous random variable, or not a random variable. So we'll start with the number of points scored during a basketball game. Well, one of the things that we need to have present is that it has to be a numerical value. So, okay, at least it passes that much for being possibly being a random variable or discrete random variable, continuous random variable. The number of points scored during a basketball game, well, can the point values be like anything? Or are there only certain values that you can hit?
Certain.
There's only certain values.
Good. Yeah, there's only certain values. So you can't have 119.5 points scored during a game. It's 119 or 120, 121, etc. So there's a discrete number of values that that variable can take on. But other than that, it is a good example of a random variable. So we'll put that one down as a discrete random variable. Here we go. Discrete random variable. Let's look at the next one. The time it takes to fly from city A to city B. So what are you thinking on that one?
Continuous.
Continuous sounds pretty good. I mean, one thing for sure is that it takes on a number value. Time is going to be denoted by a number. But yeah, it can be continuous. It could be anything within some interval. So good, continuous. How about for number C, eye color?
Not a random variable.
Nice, not a random variable. Yeah, eye color is not numeric. It's just, a name. So it's nominal data, it's not numerical data. Let's keep going. The time it takes for a light bulb to burn out. Well, it's a number. And Shane, go ahead.
Is it continuous? Kind of like B?
Yeah, it is continuous. Nice. Two more. The number of students in a statistics, or excuse me, number of statistics students now reading a book. So, discrete? Well, it's certainly a number, and it can't take on just any value. So, yeah, discrete sounds pretty good. Yep, discrete. And last but not least, the number of free throw attempts before the first shot is made. So going back to basketball again, I guess?
Discrete.
Yes, discrete. Just like part A, and the previous one, it can only take on a certain number of values. Now, the values that it takes can be shown as a distribution. Back in chapter 2, when we had a lot of data, we put it together in a frequency distribution. We defined classes and said, okay, you know, how many people landed in this class, or how many people landed in this class. So we have those distributions, and we're going to do the same thing for probabilities. So with probabilities, we're going to list things in a little table like this. One part of the table is going to tell you the value of your random variable. The other part is going to tell you the probability. And so let me give you some requirements for this probability distribution. So let's talk about that for a second. Probability distribution requirements. There's 3 of them. So the first one is that you have numerical values for the random variable. Numerical values for the random variable. I'm going to call that random variable X. Second, this is a requirement that we're familiar with in terms of probability from our previous work in chapter 4. Probabilities are between what numbers?
0 and 1.
Perfect. So all these probabilities, whatever the value of X, that probability has to be somewhere between 0 and 1. So cool. And now this last one. If you remember from a while ago, we dealt with this. That means the sum. And what it's saying here is that the total of all probabilities must equal 1. So the total of all probabilities must equal 1. Now, sometimes you have to allow for a little rounding error, because when you're listing things in a table, it's not always possible to get rid of some of that rounding error. So it might not total to perfectly 1, but if I'm going to try and quiz you on whether or not something's a distribution, I'm not going to try and trip you up by giving you something that adds up to 1.00001. All right. If it's not going to be a distribution because it fails this, it's going to be off by a noticeable amount, like be 0.88 or something like that. But that's one of the requirements for our distribution. So let's look at an example that I'll put in the chat. And you can open up in Google Sheets. So it's this little table right here. Let me put that in the chat. And gotta make sure I send it to everybody. There you go. So grab that data from the chat if you would, please. And let's put that in a table. And I'm going to do that in Google Sheets because we want to decide if this is a distribution or not. All right, I'll just put it down here. Oh, it's not doing what I wanted to do. Why is that? Let me try a different tact on this. Okay, so we've got the number of sleepwalkers is a random variable. These are a number of sleepwalkers in groups of 5. And the probability of getting 0 is 0.172, 1 is 0.363. This sounds really high. I've really never known anyone to sleepwalk, but okay, let's just go with it. We're not worried about where is this data coming from. The goal is, first of all, to decide if this is a distribution. So let's do that. There was 3 things we had to check. Well, it does have numerical values, so it passes the first one. The other thing is that each of these values is between 0 and 1. Good. What was the last one? What's the last thing we got to try?
The
So
sum.
the
sum
sum
of
of one.
Sum. So someone want to take out a calculator for me? Oh, wait. Never mind. We're in Google Sheets. Let's do this a very simple way. So go to the bottom here and type equals like you do with all of our commands. And oh, look at this. It's asking me, is this what you want to do? Sum these up? And the answer is yes. I want to sum up B21 to B26 and press enter. And I get 0.999. So what would you say? Is this a distribution, A or nay?
A.
Yes. Yeah, it is. All right. Now, it's not perfectly 1. There's a little bit of rounding error, but that's okay. All right, we can live with that. Like I said, if I'm going to ask you a question if something's a distribution or not, I'm not going to trip you up because it's 0.999. It'd be obviously different, not something that's so close like that. This is just rounding error. All right, let's scroll up here a little bit and work with a different set of data as the number of girls in 10 babies. So you go to Beaumont Hospital, you watch 10 babies being born, and you see what the frequency is of those babies. And you got 10 of them. Let's see if we can't figure out some probabilities here. All right. Let me just take care of something from the last example. This satisfied all 3 requirements. So, you know, given that 0.999 is pretty close to 1. So it is a probability distribution. Okay, so let's go back to example C here, or start example C, and take a look at that. Now, I've had a couple people show up a little bit late here, so I don't know if you can go backwards in the chat. I don't know. So let me repost the link to my Google Sheets that I've been sharing. And if you've just joined us, you should open up that link. Oh my, what happened here? Let's try this. These arrows allow you to undo. So, whew, there we go. If you were to look at 10 babies being born at Beaumont Hospital, how many of them would you expect to be girls?
50%.
50%. So 5, right? All right. So this distribution should reflect that somehow. But before I get there, let's ask a couple questions about this just to try and get comfortable and familiar with probability distributions. So we'll call this example C. First question is it a distribution?
Yes.
All right, we've checked 2 of those. 2 of those you can take a look at that, yes, you've got numerical values, and yes, they're all between 0 and 1. What's the last thing we got to do?
Sum them up.
Sum them up. Laura, did you sum those up?
I did. I got 1.
I guess I did. So, yeah, so the total's up to exactly 1, which is perfect. That's what we were looking for. So this is a distribution. That's good. Now let me ask you some questions about this distribution. First of all, what's the probability that you get exactly 7 girls? Out of those 10 babies, what's the probability of getting exactly 7 girls?
Would that be 0.1172?
Thank you, Laura. 0.1172. Excellent. But what if I asked you something a little different here? What if I asked you for the probability of at most 7 girls? Probability of at most 7 girls, which is equal to the probability of x is less than or equal to 7. Now what do I got to do? Well,
Would
that
you
in itself, go ahead.
would you add everything up, like from 0 to 1 to 2 to all that up to 7 until you get to 7?
Yes, that's exactly what you would do. You have to add up all these probabilities. So, wow. Normally that'd be daunting, except, oh, wait, we're in Google Sheets. So what we can do is, let me go over here to the side. I'll type in at most 7. So that way it's kind of like a label of what we got. Now, if I'm going to add those up, the first thing I need to do is type in this is a fill in the blank. This is your part.
Okay.
Equals. And let's type in sum. And I'll hit enter when it recognizes it. And I'm just going to click all of these things. And bam, 0.9453. So cool. That's really nice. Are you okay with that? Are you able to get that? The same number on your Google Sheets? All right.
Wait, what all did you add?
So let me click it here.
Okay.
You added the numbers, all the probabilities between 0 and 7.
Okay. Okay, got it.
Cool, cool. Actually, you know what? I think I want to put this someplace else. I'm going to put it over here. Because eventually we're going to come back, actually in just a minute, we're going to come back and do some more calculations with this. That's going to require me to use these extra columns. So I'll just reduplicate that one over here and get rid of it from here. If you hit the delete key on your keyboard, it's a nice convenient way to erase certain calculations and values. All right. Let's do a couple more like this. One thing I want to point out is relative to this one, probability that x is less than 3. What values of x satisfy this that are on our table?
Would that be 2, 1, and 0?
Nice, 2, 1, and 0. So what's going on here is that this is really the probability that x is less than or equal to 2, because you're not including the 3. So there'd be a probability that x equals 0, or x equals 1, or x equals 2. And I'm thinking that's going to be about 0.0547 or something like that, but that's just a guess.
Yeah, that's what I got.
All right, so let's do less than 3 equals, and then sum, 0, 1, and 2. Perfect. Perfect. And finally, let's do one last one. Now, because we have Google Sheets, we can do this a couple ways, but I want you to appreciate the rule of complements as well. So let's look at the probability of at most 9. So, wow, it's like almost everybody, right? So probability of at most 9. Does that include 9 itself? Should I put less than or equal to here?
I feel like it should include 9.
It should. Yes, thank you. So it does include 9, and that would mean the probability of x equals 0 or x equal 1, all the way up to x equals 9. And there's nothing wrong with calculating that kind of the direct way. I'll actually show you 2 different versions of this calculation. But let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the number of girls in our set. And this probability of at most 9, that represents everybody here. Now, if we give this set a name, call it B, then what would be a name for this set right here?
B bar.
B bar, excellent. It's the complement of things. Now, because we're doing this on a spreadsheet, it's not really a big deal to calculate it directly. But the cool thing is we could also calculate this indirectly. So I could calculate this probability as the sum of all these probabilities, or I could do it as 1 minus a probability of something else. 1 minus the probability that x equals 10. 1 minus probability that x equals 10. So nice, it should give me the same thing either way. And let's see that it does. But I'm just trying to practice your rule of complements for you a little bit more. So at most 9, here it is directly equals the sum. And now I want all of these. So there. And then let's try it indirectly. So to equal 1 minus, and I don't even have to hit the sum key. I was just subtracting that 1 value, and bam, I get the same exact number. So this is directly, this is your complement rule. Cool. It's just nice to know that you get the same thing either way, and you should be able to calculate them both. It's just sometimes it's very convenient to use a rule of complements. Very, very convenient. All right, what are we looking with that one? We're going to stick with this example some more, but I want you to get used to and comfortable with these probability things. So we okay with those? All right, resounding yes, thank you.
Yes.
Now, I asked you earlier, I think Nan gave us a nice answer. She expected 50% of the girls here, 50% of the babies here to be girls. So you expected 5. But how do you actually calculate what's expected? So let me talk about the expected value here, or the mean for a random variable. So expected value. Now, expected value is what we typically use when we talk about random variables, but it also goes by the mean. Expected value for a random variable. How do you calculate that? First of all, we're going to go back to some familiar notation, or hopefully is somewhat familiar. And that's the Greek letter mu. and that's going to equal the sum of x times p of x. So the sum of the product of the value of a random variable times its probability. Yay. So let's do that, and then we'll come back and learn how to calculate the variance and the standard deviation. So the nice thing for us is that we're doing this on Google Sheets, and it just makes the calculation so easy. You feel happy that you're not doing this by hand. So up here, I'm just going to label my next column x times p of x. Just to remind myself what I'm calculating here. Go to the first cell, cell C3, type in an equals key, and then click the first cell in column A, so A3, not exactly the first cell, I guess, but the first probability there, times this cell. So that's your x times p of x, and of course, we can do the product in our head, but that's not really the point. 0 times that gives me 0. Okay, fine. But now I got to repeat that for all the values in the variable. Now you can copy it, copy, cut, and paste. But to me, the most efficient way is just to drag this down. Wow, how nice. We're not quite done yet. We got to figure out what the sum of this is. But again, that's not too bad because we're working in Google Sheets. Equals sum of all these. So when you click and drag and highlight, you should get the sum from C4 to C13, or whatever, wherever your values are. Actually, technically, I should go a little higher. Should be C3, but in this case, it didn't matter that I missed that first cell because that first cell had a 0 in it. So we're okay there. You should get 5 when we total this up. Yay. So that's your expected value here. So for the number of girls and 5 babies, the expected value, on average, you should get 5. And that makes sense. Are you guys able to get that total on your sheets?
What is it that you put in Google Docs? That like
For which part?
to make it sum up those big numbers right there, like to make it sum up to 5.
All right, so this column here, I started out up at the top here, right underneath my x times p of x. And what I did is I clicked equals. So let me redo that calculation. Equals, then you click this cell, and then the asterisk, which is above the 8, times, and then this cell. Now that puts a 0 in the first column, but then you can take this little square in the corner and drag that formula all the way down so that it populates the rest of that column with your formula. Did you get it this time? At the bottom of that, we're going to add up all of those 11 different products, and that's just going to be the sum from C3 to C13. So while you're double checking yourself on that, the expected value of girls and 10 babies is 5. So mu equals 5. But now we're going to go a little bit further. We're going to calculate the standard deviation. So what's the standard deviation? Well, before I describe the standard deviation, I've got to do another calculation, and that's the variance. So the variance calculation is going to look like this. It's going to be the sum of p of x times x minus mu squared. Now, do you remember relationship between the variance and the standard deviation. We haven't
Isn't
used
the
it much.
standard deviation just like the square root of the variance?
Beautiful. So the standard
Perfect.
deviation is the square root of the variance. So the variance is denoted with a lowercase sigma. That's going to be your sigma squared. The standard deviation is going to be this formula underneath the square root. So we're going to spend some time calculating this thing right here. That's what we're going to work on next. It's calculating the variance and then the standard deviation from that. So let's double check back here. I'll give you a second to grab that formula. Okay, we're going to continue working with this sheet. I want another column here, and that column is going to be a little bit more complicated than the previous one. It's going to be P of X times X minus mu, and then you can hit the shift key and then 6 to get that little up arrow, so we can put in a squared. So P of X is X minus mu, or P of X times X minus mu squared. That's what we're going to type in. Now let me strongly suggest that you not type in mu based on some cell number. You just actually type in the value. If you don't, I can't be responsible for what happens. It gets a little tricky when you're working with spreadsheets if you're going to copy, cut, and paste from one formula to or one cell to the next. So let's just keep it simple, and we'll actually type in our values for mu when we do this formula. There is cool stuff you can do that locks things, but I'm not trying to teach you spreadsheets here. All right, so what do all our Google Sheets commands start out with?
Equals.
Equals, thank you. So equals, and then I want P of X, so I'll click this column, times, and then a left parenthesis, so times is above the 8 again, X, where's my X? What column is X in? So
A.
X is in, whoops.
P?
Yeah, so X is in column A. And let me see, I'm not sure why I can't get rid of this. Done. We're done. Thank you. So I'll type column A for my X minus mu, and we're actually just going to type in the number 5, and then keep going with a right parenthesis, shift 6, and then a 2. That's going to take that difference and square it. So you should have a calculation that looks like what I am displaying here. B3 times left parenthesis, 83 minus 5, right parentheses, and then squared. So it should give you 0.0244. Let me do that one more time again, starting from scratch. So equals P of X, that's in column B, times left parenthesis, our value from column A, that's our X, minus 5. Type in the number for mu there. Don't rely on hitting some cell. Then shift 6 to get the square, that little hat. There you go. Let's drag this all the way down to column 10. It should fill out like that. Now we don't just look at those and go, oh, hey, cool. We need to total them. So let's go to the bottom of that column and total them. Does everyone have what I have here in column D? I can't look over your shoulders like I can in a classroom, so I need you to be truthful for me.
Yes.
Okay. Thank you. Let's go to the bottom and sum that up. Equals sum. And then just click and drag all the way up to D3. So you want the sum of D3 colon D13. And if you don't want to click and drag, you can just type it in. You don't have to click and drag, although that seems to be a pretty easy way to do this. So, bam, there we go. 2.5. Nice. So that's our variance. Yay. Let's see about the standard deviation. So to get from the variance to the standard deviation, somebody new that I haven't heard a voice from yet today. What do I have to do to the variance to get the standard deviation? Equals what?
Square root.
Square root. Now I don't know what the square root command is, so I'll just start typing in SQ. Oh, and there you go. Square root. Square root of this cell gives me 1.58. Nice. So we got a mean of 5 and a standard deviation of 1.5811 for the variance in the number of girls in 10 babies. So let me write that down.
I have a question
Please.
regarding the variance equation. When when I wrote it, was there a sum? It's like sum, the sum
Yes.
sign, and then px, and then parentheses. Like, all right, yeah. Did we use the sum though, like there?
Yeah, so, we use a sum at the bottom. So in these individual calculations, you're just calculating what happens at any one cell. But the sum part was at the bottom. So when we got to the 2.5, if you look here, that's the sum of this entire column. So one of the cool things you can do with Google Sheets and Excel is click here inside your cell range, and it'll highlight what you're summing. So you can see that I'm summing up all these values here. So that's where I'm getting the variance, is the sum of the highlighted values in column D.
Okay, but like on the written one, I don't know. Like when we write it, you have like, it looks like it would be like sum times px right there, like for variance.
Well, it's the sum of all of these things. It's not a times. You have to understand what this represents. It means the sum of each of those cells. So one at a time, you have to calculate all of these products and add them up. That's what that notation means. So for instance, a lot of times, if I have some data, let's say X is a random variable and it has values of 3, 5, 8, 11, 15, then when I write sum of X, it's not this times this. It really means 3 plus 5 plus 8 plus 11 plus 15. That's what that would mean.
Okay, thank you. I understand it. Thank you.
Sure, sure. No, I appreciate the questions. I do. Thank you. Are we okay with the calculation here? Because we got to take this calculation a little bit further, but I don't want to go further unless I'm sure that everyone understands what's going on.
For the part that on the graph on the side where it says like mu minus 2 sigma, what exactly is that in the plus?
Oh, great question. Thank you. Let me answer that.
Thanks.
Yeah. Let's go to the range rule of thumb. Let's see, handling. handout, range rule of thumb. Ah, there we go. Should be on your handout, I think, and I hope. Range rule of thumb.
Oh, this was in a previous section, wasn't it? Because I remember it from the homework.
Yes, yes. So it's coming back to haunt you. So the range rule of thumb helps us identify values that are significantly high or significantly low or not significant. The kind of ordinary garden variety of values of a random variable. So what we have to do is we have to calculate a cutoff line. So that cutoff line is 2 standard deviations above and 2 standard deviations below. That helps signify for us significantly high and significantly low. So let's do that for the girls in our little study here. So remember we had anywhere between 0 and 10. So let's draw ourselves a little bit of a line here. Okay, so again, we're looking at the number of girls and 10 babies. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I want to know what's typical and what's unusual. So what we need to calculate is mu minus 2 sigma and mu plus 2 sigma. Now let's figure out what those values are. So, okay, we'll do that. And that's what I have up here, is that mu minus 2 sigma and mu plus 2 sigma. So for this one, I'm going to type equals. And it's up to you if you want to type in the number 5, or if you just want to click this cell. Either way, you get the number 5 there, minus 2 times. I don't really feel like typing in the number 1.58113, etc. So at that point, I can just click this cell down here for the standard deviation. So that's your mu minus 2 sigma.
Can
So
you do that
more-
one more time?
Yes. So for me on my sheet, when I did this, I clicked mu, which was right here, and then a minus, the number 2, asterisk for times, and then the standard deviation was for me in D15. And that should give you about 1.83.
Thank you.
Now, try yourself with mu plus 2 sigma. So pretty much the same calculation, it's just a plus here as opposed to a minus. So equals mu, whoops, I don't want to type in mu, sorry. Equals mu, and look, you just type in the number 5 if you want. You don't have to go chasing around for this one. But I like referencing the exact value. Mu minus 2 times, which mean not minus, how about a plus? Plus 2 times sigma. Yay. So let me put in those values into our table. Or not into our table, but into our number line. Are you able to get those numbers off of your spreadsheet?
Yes.
Yes.
Good deal, good deal. We'll practice one more like this, where we're trying to find what's significantly high and what's significantly low. But for us, let's write down those numbers. So 1.83 and 8.16. Okay. Now the strange thing is that, can you have 1.83 girls in amongst 10 children?
No.
No.
Same thing here. but that's okay. It still gives us a cutoff line. So that cutoff line is right here and right here. Well, it doesn't matter if I got it exactly proportional or not. But what it really means for us is that anything here, those are your typical values, or that's not significant. So typical values, not significant. Well, what's not typical then? What would you say about having 0 or no girls, or 1 or 0 girls?
Significant low.
Good. Significantly low. And then in contrast to that, over here, that'd be significantly high. Nice. How are we looking on that one? We'll do another one like that in just a minute. But were you able to get those numbers, and do you understand this conclusion? That's based on the range rule of thumb. That's what we're using to figure this out, is the range rule of thumb. Basically, it says that your typical values are going to be within 2 standard deviations of the mean. Anything outside of that is atypical. So this is your range rule of thumb. Cool.